everyone. So this week what I want to talk about is something, is this really powerful technology that's going to be helpful for doing our data analyses called regular expressions. Regular expressions are a type of pattern matching formula, I'm going to call it, function. It is a way to match patterns in text it's a way to match patterns in text. That's sort of the basic description. Regular expressions, but the thing about regular expressions is that regular expressions don't just exist in one place. That is, it's such a powerful tool that actually every programming language has basically some version of regular expressions. So what we're going to be talking about today, we're going to look at first in the context of OpenRefine, which we've been working with. So we're going to get familiar with regular expressions and kind of what they can do and how they work. And then this is something that we're also going to bring into our Python work as well. So while the sort of specific details of how regular expressions are written may vary from language to language, the principle of what they do is consistent across any kind of tool or programming language where you might find them, right? And this is really important because there are some kinds of analyses that even with tools like OpenRefine, which gives us a lot of power in terms of looking at things like text facets, numeric facets, timeline facets. We can do clustering as we looked at in class. It does give us all of these tools, but nothing else does what regular expressions do, right? So although these can be a little bit challenging and kind of tricky to work with, they are, as I said, super powerful and super unique. And so it's really worth understanding a little bit about how they operate. So in order to kind of contextualize regular expressions, let's look at a particular data analysis task that we might want to do. So what I've done is I've sorted our start station name fields by by name, right? I've done a text facet on the names, and one thing that I can see is that there are many that there's some consistency, right, where we see a lot of city bike stations existing on, say, a particular avenue, right? This shouldn't surprise us. It's interesting that there's one on both 16th and 18th Streets and First Avenue, actually. But we see that these are sort of clustered around the cities in various ways. So one of the things that I'm going to look at here is, just because this is sort of near where we are, I'm going to look at the question of Central Park West. And in Central Park West, what we see is that we see a couple of things. So first of all, we see that we have, various, we've got one at 100th Street, 102nd, 68th, 72nd, 76th, right? And so the question here is, what if I wanted to determine all of the places, what if I wanted to see all of the start stations that were anywhere on Central Park West, right? So it appears at first glance when I look at this that, well, I found them all, right? This one actually I'm going to edit because you can see for whatever reason they've actually labeled it Central Park W instead of Central Park West, which is not consistent. So even within a data set like this, which is really organized and really clean, sometimes you will get little inconsistencies like that. But the other thing that I don't know is I don't know if when they're labeling these stations, they always put the street names in the same order. And in fact, I believe they do not. I think it actually has to do with which directional corner or which side of the street the city bike station is on. So the way that I can confirm this actually is, having looked at this earlier, is that although a lot of the Central Park Wests are clustered at the top there, I can actually see if I come down here that there is another station on West 106th Street in Central Park West. Now, how would I know that, right? How would I actually go about looking for that? I mean, one way is to do what, in a sense, I just did, which we would just call inspection, right? Just looking at the data. But obviously, as I'm sure you all can appreciate, this is very time consuming. I could potentially do this with something like a find and replace, which might work in this instance, although it would still take a long time. And it wouldn't actually give me a way to label whether Central Park West was present, right? So one of the things is that we can use some of our existing tools, like we can use things like find in order to find something, right? But it doesn't actually provide us a way to efficiently label whether that thing was found in a particular entry, right? And that's what we want to be able to do. We want to be able to say, look, these are all of the stations, right? I want to work only with the stations that exist on Central Park West, for example. So this is where regular expressions come in. What regular expressions can let us do is say that we want to look for a particular string, right, set of letters, set of words, within a given field, no matter where they appear, right? And it can do much more than that, but that's sort of a basic example of what it can do. So that's what we're going to look at here. And the way that we apply regular expressions is that we are going to create a new column, okay? So the way, because what we're going to do is we're going to essentially use this regular expression to test whether the value in start station ID for a given row, whether the text in that row contains the words Central Park West. If it does, we're going to tell the new column to have a value of true. And if it doesn't contain it, we're going to ask it to give it a value of false, for example, right? And what this will let us do is then we can text facet on the new column, and that will isolate for us all of the rows that have what we're looking for. Now, one thing about applying regular expressions is we want to, because it can be a little tricky, we want to make sure that we are looking at a set of values that can help us interpret whether or not our regular expression is working. What I mean by that is, now, assuming that I didn't know about this West 106th Street in Central Park West, the first thing that I would do probably is select some of the existing Central Park West values. Okay, so I'm just going to highlight this one. And I'm going to include that one. Oops, that should also be included, right? And so what I want to do is I want to narrow the set of data that I'm looking at in OpenRefine. I want to narrow that down to things that should match my regular expression, right? That I should get a correct value for, a positive value for. And so to do this, I'm going to come here, I'm going to say edit column, add column based on this column. Now, you can see, first of all, I have to give it a name, so I'm going to say has CPW as an example. And you can see that the first thing that it says is value. So this is creating a new column. It has already decided that the language is going to be the GREL, the Google Refine, the Google Regular Expression Language is what that stands for. Okay, and what I want to do is I want to do a match. I want to say, look in the value of this column, and I want to see if you get a match for whatever it is I'm going to put in there, right? And so I could do this by just writing, I can test that this works by just putting in, I'm just going to put in the actual value that appears here, right? So I can say West 68th Street, right? And if I am correct, then it is going to give me, oddly, right? If I'm correct, then it's going to give me these square brackets. Now we're going to add something to this formula so that it gives me something more meaningful than square brackets. But if it doesn't match, right, so we see the Central Park West and West 72nd, it gives me the value of null. In other words, no match exists, okay? So that's the basic concept of how they work. But of course, I don't want to match the entire thing. I just want to match the Central Park West part. And so in order to do this, I'm going to use a regular expression. What the indicator, so the same way that we write an equal sign in Excel to say, hey, we're using a function here, we use forward slashes to wrap whatever it is that we want to be looking for in our regular expression. So the only thing that I want to be looking for in my regular expression is Central Park West, right? I want to match anything that contains Central Park West. And I'll point out here that you can see once again that I'm wrapping in round parentheses. That's the way that I make sure that it's matching all three words together in that configuration, Central Park West. Well, the problem is that if I look at this, I can see that it actually doesn't seem to be matching any of my values, right? Now, the reason why this is the case is because regular expressions demand that we account for every possible character that appears in a string. Now we'll go over this in class, but I like to think of regular expressions as being like a turtle walking on a number line, right? Or walking across our text, right? Basically, it moves to the first space and it looks at the regular expression and says, does this expression, does the letter that I have, is it accounted for in the pattern that you have provided me? Well, in this case, the answer is actually no. Even though these start with Central Park West, because even though it starts with Central Park West, there's material that comes after it, right? And so what happens is our little turtle will get to the end of Central Park West and be very happy, and then it will come to a space and say, wait a second, you told me all I'm looking for is Central Park West. I have a space here. Obviously, there's not a match. Now, the way that we compensate for this is that regular expressions let us use what we call wildcards. So we can have a symbol that means match anything you want, right? It can be a space, it can be any letter, anything you want. And the way that we represent that is an asterisk. An asterisk, in this case, the way that we do that is with a period, okay? A dot means match anything you want. But even so here, right, that only counts for one character, right? And we might have any number of characters following that appear subsequent or prior to Central Park West in our string, right? Because here, okay, I can't count this as probably 8 or 10 characters, but if you notice here with West 102nd Street, it's going to be one more. So how do we deal with that? Well, this is where our asterisk comes in. So again, we have special symbols that allow us to describe how many times something should appear. And in this case, asterisk is a very special one because the asterisk says you can have no characters there, or you can have as many as you want. So basically, we interpret the asterisk as a character as whatever precedes it appears 0 or more times, right? So if I say, look, you can have no characters before Central Park West or as many of any kind of character as you want, right? Then that will take care of my instance where I'm looking for 106th Street in Central Park West. But I also need to do the same thing on the other end, right? And make sure that it says, hey, you can have anything you want on the end as well. And you can see as soon as I added that, right, it's like magic. It's like, oh yeah, I totally find that because now you've given me a way to say, okay, there's anything or nothing. And then I found the entire string of Central Park West. And now I have found any number of other letters after that. And every time as I'm going through, I can say, okay, you told me it could be anything. You told me it could be anything. You told me it could be anything. And then it gets to the end of the string and the entire string has been accounted for, right? The entirety of Central Park West and West 68th Street, et cetera, et cetera. But the truth is that we really don't want to have Central Park West be the thing that shows up in our resulting column. What we really want is a true or a false that says, hey, CPW is in here or it's not, right? Because this is going to give us something to facet on. And especially as our regular expressions get more complex, it's going to ensure that we can kind of make sense of it. And of course, you'll need to detail in your documentation exactly what the regular expression output is supposed to be, right? What is it matching? Because it won't be that obvious from the regular expression itself. So the way that I'm going to do that I'm going to transform that, is I'm going to use another function called isNotNull. And if you remember, when it wasn't matching, it gave a null value. This time, when it is matching anything, it's going to give, it gives something, which is not null. And so when I say isNotNull, it shows up as true if there's some kind of match. Now, the one thing I want to highlight here is that for testing purposes, I have pre-selected things that I know that I want to match. To make sure that I get everything that I am looking for, I am going to make sure that I do run this on my entire data set. So you can see I didn't actually create the column there. I was just testing out my regular expression to make sure that it was doing what I wanted. And so now I'm going to come back and I'm going to do the same thing again, just making sure I apply it to the entire data set. And you can see that happily, right, it's also not matching things that I don't want. And I'm going to click OK. And when I do this, I get exactly what I was promised, which is a new column. And if I do a text facet on this, I can now check. And by choosing the true values, I can go now through the start station names. And I see that, yes, all of them match Central Park West. And in fact, I found 2 where Central Park West was at the end rather than at the beginning. So hopefully you can see from this that what regular expressions let us do is they let us match patterns that we find in individual fields. We can also use them on sort of open text files, but that we really wouldn't have a good mechanism for filtering out in any other way. So we'll start playing around with these this week, and we will continue to work on them in the coming days. Okay, see you all soon.